Thank you very much, Colin. First of all, thank you for the invitation. There's probably a lot of you who don't know who Valmet are. It's great as a sales guy. I've been here 10 years and normally the first 10 minutes of any conversation is explaining who Valmet is. For a company that turns over 5 billion, most people have never heard of us. So depending, if you're from the paper industry, you will have. So I work in a part of Valmet that manufactures control systems. And I'm sure I'll elaborate on that a little bit. Last year we launched a new product called DNAe, which is an evolved version of DNAe, which some of the people in the room I know have got. So really it's the sort of next generation of control systems and how things are changing from maybe what some of you are more familiar with. I'm clearly not going to read all of this out. I'm just going to talk through it. So that's the sort of, this is everything that's in the slides, and mainly sort of I'll try and talk about what some of the drivers were that made us launch DNAe. Megatrends impacting industry transformation. I don't know how many of you, like I say, looking around, quite a lot of you will have retired now. It's kind of a great time right now, to some extent. You know, we were told a couple of years ago that you know, the sort of traditional power industry, DCS for power industry, was a sunset industry. It was going away, and now I spend a lot of time talking about hydrogen and carbon capture and different things. And guess what? They all still need control systems. So regardless of where the power's coming from, it still needs control, still needs information, still needs displaying in a control room. So resources, climate change and environmental awareness is a huge thing for us in Valmet. We have been on the Dow Jones sort of top 100 index for sustainability for the last 10 years. We've got a gold EcoVadis rating, which I had to look up. I didn't even know what EcoVadis was. But it's, you know, these are the kind of questions you get asked now when you're talking about sustainability. So it's a big thing for us all through the supply chain. New technologies, as I say, sort of whatever, the automation and digitalisation. You could argue that we're just doing variations of what we've done for 40 years. You know, it's just you're changing it and you're saying it's modern, but I'm making it cloud, putting it in the cloud and making it web-based and things. And for, you know, for all the things I'll tell you today, there are people out there who prefer a system that wasn't connected, that had no connection to the outside world, and just build it like you did in the 1980s. And again, a changing human behaviour. So I don't know, interesting one. For me, changing human behaviour is the sort of demographic of the people that you're dealing with, realising that dealing with somebody, for argument's sake, your age, you know, compared to, you know, somebody my age, you're growing up with different attitudes as a buyer, different, you know what I mean? That generation of buying something, maybe even just on a phone, you know, not going through the same procedures and the same kind of values, I guess. More megatrend driven challenges. Again, try not to talk about some of these too much. Cybersecurity is obviously a huge one. Certainly right now, you know, we've just been the first DCS manufacturer to sort of get the accreditation. Everyone tells you they're working towards it. In the last few weeks, it's, you know, the cyber secure, sort of inherent by design. It's a great one to have, and you know, my argument is though, if I deliver you a system today that's secure by design, by tomorrow it's probably under attack. You know, so it's not just saying, oh yeah, it's cyber secure, it's great. You know, dropped it on your door. It's how you look after it after that, and people are obviously concerned about it. And at the minute we're ahead of the game, so that's good. Again, as we go towards this sustainability, energy transformation I mentioned earlier, sort of different ways of producing electricity, and then labour and skill shortages. Apparently the silver tsunami is on the horizon, and there's not enough young people coming through to deal with the increase in all these jobs. So again, do you make products that help them, you know what I mean, make their job easier? So again, customers' key value drivers for increasing autonomy. Improved safety, that's pretty much a given these days. The difference will be some of the stuff I'll talk about today. From an operational point of view, you're kind of moving away from two guys either end of a walkie-talkie, one in the control room, one in front of a panel. You know, that's not necessary with the modern technology. Asset performance over the life cycle. Again, certain customers weren't necessarily bothered about, you know, asset performance, optimizing something. The price of electricity now is such that if you can squeeze a little bit more out of it and get more power, it's worth a lot of money. A lot of money now. So the payback on things like that. Again, reducing the impact of an aging workforce, we spoke about. Reducing costs by centralising operations. Again, kind of great in principle, you know, with customers who've got multiple versions of the same product. And again, improving sustainability. So all those things are drivers for us, you know, making a better control system. Obviously combining sort of the control room, how we look after a system, and then you know, how it's operated in the field. This just says Valmet's over 220 years old. I know that sounds, you know, as a Finnish company, sounds a bit crazy. Really, if you go to the factory that runs the business that I work for, they manufactured and invented one of the first black boxes. So for aircraft, it was born from a black box, the controls and the pneumatics. That evolved into sort of late 70s and 80s, the first true DCS. That's evolved since then through the different years. This is just industry speak about, you know, the industrial internet and things, linking machines together, data, us launching a new user interface and then launching a new product. The one thing that makes Valmet unique is every product that we've made since the 80s has been forward compatible. We've never sort of left the customer high and dry. You know, we don't make a product obsolete and say we can't support it anymore. So if you've got a system that was built in the 80s and you obviously, you know, becomes a bit like Trigger's broom. You replace the hardware, but the code and the software will operate straight away. So you might replace the hardware, but that original code will still run in the modern, you know, whatever we deliver today, tomorrow. I say for a company you've never heard of, if you're in pulp and paper, you will know Valmet. They're sort of between number 1 and number 3 in all pulp and paper, machines, industry. Globally, we've delivered 1,200 power plants. And again, like I say, you've probably never heard of us. You may have heard of Metso before. But trust me, 1,200 on a global basis is a lot. In the UK, we have the big niche in the UK is waste to energy. I was just saying, we always say between 60 and 70% of all the waste to energy plants have our control system installed, which again makes it, you know, quite a good niche for us. Marine, believe it or not, some of the biggest ships in the world, including the sort of modern cruise ships, 850, and that's like doing a small floating city. So I think the biggest one, the Icon of the Seas, which is the biggest cruise ship, that's got a Valmet control system, and they have literally like hundreds of thousands of data points. And process industries, we do, again, it's kind of like, it's not like a best kept secret. We do loads in Finland. If you ask me for any experience, if we've done anything, we've done it in Finland because we're a Finnish company. We do sort of refineries in Rotterdam, but we don't really do UK ones. You know, it's just the way Valmet is. So I'd say globally, we turn over 5 billion, and as I joked, you probably never heard of us. That'll be our next marketing campaign. the biggest company you've never heard of.
Life is full of challenges. In life, you have to be ready for the unexpected. Ready to evolve. Our next generation distributed control system, Valmet DNAe, is ready. It carries generations of innovation and experience and is designed for efficient operation and easy onboarding. We understand that people are behind your success, and our fully web-based DCS lets your team experience control at every level. Global collaboration is effortless with the right information at hand for every user, remotely or on-site. With advanced analytics and reporting tools, your team has the facts they need to control and optimize the process to meet your production, quality, and environmental targets. The system helps you pave the way towards the autonomous operations of the future. Valmet DNAe is easy to implement, configure, and maintain. It's been built with lifetime compatibility and support. When situations change, it's important that you have a system that keeps you aware, in control, and ready for the challenge. At Valmet, we believe in collaboration and long-term commitment to move your performance sustainably forward. Our new DCS has been built for you to experience control at every level.
So you see there from the control room, probably quite a lot different from what you're used to seeing in terms of just the layout, really. I was asked to make it not too techy and not too much of a sales pitch, so I haven't got loads of detail on the screens and everything, but those curved monitors, to be fair, I was hoping to show you how we do it, but can't get on the network here. Those 49-inch curved monitors allow you to build up the system however you want it as a user. So instead of having, historically you would have just seen loads of fixed screens and people dragging stuff across from a screen. But the new system, you can have video walls, these curved screens, monitors, really sort of innovative stuff. And we now do what we call a UX design, where we go into a control room. We always find it a struggle, certainly as a sales guy. If you asked an operator to design a system, it would probably be fantastic because they operate it on a daily basis. As a sales guy, we end up talking to, I don't know, a contractor and someone who designs it, who goes, we end up like, not cheapest chips, but, the lowest point over the fence kind of thing. So, as cheap as you can make it just to get that job over the line. Where in reality, we offer that system, so for argument's sake, if you wanted to upgrade to the new user interface, somebody comes in, we've got desks that move and all this wonderful stuff and do like, even to the point now where I think we're doing treadmills, where the operators are there, operate a system on a treadmill, so if they want to walk while they're working, I know that sounds, what I mean? Probably if I'd have said that 5-10 years ago, you would have laughed at me, So, but that's, that's the way things are going. People care, don't necessarily want you sitting there all day just, staring at the same screen. So, going into sort of how we achieve this, again, so you saw the video, and it's, this sort of, whatever you want to call it, the tagline, to future-proof DCS. Combining OT and IT, and again that's probably something over the last few years that's before probably just sold the control system and worried about how it operated in its own nutshell. Now you're getting more IT people and network people coming into a room and concerned about connections to the outside world. Well, now we're trying to sort of answer both of those. So instead of where the control system, it was always secure and we had a secure tunnel to go in through. There was only one way in and everything was tracked. Now by changing the design, you're having to consider all of these things. And then really what happens with the data going out from a plant, so from a management point of view, if you've got multiple plants, do you want to sit in a location somewhere? and look at all those plants, regardless of who the manufacturer is. And I know that, you know, it's no different than if you've been around for a while. Pi does it, and, you know, using OPC connections and things like that. This system will do it. You know, if you've got all Valmet systems, pretty much talk to it without a lot of extra cost. So again, some of the tools without the configuration tools. The main differentiator with the old DCS was it was function block diagrams, rather than everyone's familiar with ladder logic. Apparently the new one, I've not seen it yet, how you do it, but you can integrate different forms of, we still prefer function block diagrams, but you can integrate ladder logic into it and different scripts, different text. So a bit of flexibility and an acknowledgement instead of doing it the one way we always did it. Actually, trying to change it again. The user interface is a big thing. Again, because that's the key to it. That's the bit that everyone sees. No one kind of looks. You go into a control room. No one wonders what's in the cabinet. No one really wonders what's under the hood. It's what are you displaying now? What information is there? So again, how do we do this? Empowering people, reaching production quality and environmental targets. Another big thing, we do monitoring systems and things. As I say, squeezing. We have optimization software now, just to squeeze performance out, increase, help you. And it's kind of a bit weird at times, because what we think when we launch something and say, we'll monitor, for argument's sake, looking at the boiler, and say you're burning something and you're going to replace your boiler tubes. Normally we think that's a bad thing because you're spending money on the boiler. Some people just look at it and go, I'm going to burn a load of absolute garbage and max that out because I'm going to replace, I know the tubes are going, so I'll burn a load of cheap rubbish and get as much as I can out of it. We prefer the optimization. As I say, we look at payback figures and things. We tend to, sometimes customers look at it differently than we do. Again, this path towards autonomous operations, it probably just means less people. I'm not sure you'll ever have a system, without human, some form of human interaction. You'll never just leave it and let it run. And then one of the big things for us in the UK is, the way the system evolves. The way we're structured in the UK, there's about 40 people in automation. Most of them are engineers. Most of them are follow-up. We've got something like, I think 94% of all our installed base has a maintenance contract. So that says we look after customers, and they come back to us. So there's that commitment to keeping the system, keeping it going, really. Yes, it costs money, but it doesn't fall over, and if it does fall over, we can be there within 4 hours. So again, so this is talking about the new user interface. Again, like I say, I would have liked to have demoed it, but it's a little bit different in terms of the way you can build it up as an individual, so you can have your own preferences. So when you log onto a system, and say you have a preferred setup, even down to shift patterns, we can switch between dark and light. But whatever, when you log on, your preferences are there on the system. So if you follow another user at the minute, you either maybe share or work all the same. The new system is such that when you sit down and log in, it's got your preferences. So however you've built it, whatever your individual preferences are for the control system, that's how it'll appear. And again, a lot of the tools and the sort of data behind it. The next bit, when I talked about the sort of my experience, but having walkie-talkies and things, the new system, the new user interface allows you to interrogate it from a tablet, even down to a phone, to be fair. So you can have access to the control system on a mobile phone. So if you've got good data coverage throughout the plant, you could walk with a tablet and have access to the control. So if you need to operate something, so what I'm saying about the walkie-talkies, one man now can be sort of stood in front of a panel, lock something out, do whatever he wants, and do it all from a tablet or even from his phone. So, those kind of things. Moving away, it's moving away from the traditional control room. With the new one, we're kind of all familiar with a control system being fixed at a site. With a web-based system, the control room could be anywhere. Your production could be in Teesside, the control room could be in North America. Because you're accessing it through the cloud, it really doesn't. You know what I mean? It's not about that fixed space anymore. It's not about having it in one place. And theoretically, you could operate multiple plants from the same location. So we think it's easy to use. We've got one environment that does all of this. From a training point of view, we think once we train the operators, you should be able to program it yourself, and if there's a fear of that, obviously we can help out and do extensions and things. But I've sat through some of the training, and if I can program a function block diagram, I'd like to think anybody can with the right training. So how does this work? So this is some of what I was talking about. So global collaboration. Just trying to show what I was saying, really. It could be anywhere. It's obviously secure. That's the main thing, the access into it. Everything's logged down to individuals. So again, none of this, no one touched it, nobody saw it. The thing fell over. It's down to individual logins, down to sort of milliseconds, so you know who's done what, where, whatever. Everything's traceable. You can create your own dashboards and reports and things, share information across different locations. So again, this is, like I say, talking about some of the things I've already mentioned, really. Remote control rooms. So again, this screen, these sort of curved monitors are what I was talking about, where we like to show that now. So we have what we call 3 levels of control. So the top one up at the top, we'd normally have big screens with sort of like plant information, things relevant to the plant, power produced, that kind of thing. Then on the curved screens on a local level for the operator, and then a tablet as well, right down to individual process items, so a pump or a motor or whatever. In doing this and having all of this data, it should be easy. I don't know, I know you guys use it. Do you use it much for reporting or constructing your own reports? Yeah, it should be. I mean, the new one's just drag and drop. Like I say, we say it's easy. We can train you to do it, or we can set up reports for you. And the reality is, once you've set those reports up, it'll either drop into your, it can drop into your inbox and say, here's the plant, here's the report, here's the emissions, whatever it might be. On whatever frequency you want to use it on. So again, this is sort of a little bit about the engineering tool. Some of what I was saying earlier. So it's a web-based configurator using, like I say, different engineering tools than we certainly did in the past. So they're sort of IEC programming language standards and troubleshooting. In terms of adding things, adding projects, like I say, nothing to stop you with this system. If your staff are trained properly, they can add things quite easily to it. We obviously offer training courses, or we tend to do it again. So we'll do extensions and sell those things. But again, quick. Like I say, in the UK, got a great support team. So if it's small, small add-ons and things, we can deliver it. If not, if it's something larger, the way we're structured, I haven't really talked about, but the same engineering teams that deliver capital projects can do extensions and things like that. So again, from an end user point of view, how do we reach your production quality and environmental targets with the control system? So again, it's high availability system, both in terms of hardware and software. I should have said really we do that. The hardware is a Valmet product. We don't use other people's I/O. It's our own hardware. We write the software, so it's not like where obviously certain manufacturers have licensed assemblers, integrators. We do that, but only in niche industries. We tend to, if we sell a project, we deliver the hardware, fact test it, and write all the software as well with the cybersecurity built in. Say long life cycles. So I'd say waste to energy. Probably a lot of the waste to energy plants, 25 years maybe minimum run, and then some after that. The ones that were 25 years old, or even older than that now, are getting life extensions and things. So we have to sign up to support that for 25 years. So again, what I said earlier about always being forwards compatible, we're always able to support it. We've never left anyone high and dry and slammed the phone down saying we can't do that anymore. And again, it's a scalable system, so you can do it from like 100 I/O, small system. Might not be the cheapest at a small level, but then into tens of thousands, hundreds of thousands, and as I say, cruise ships, basically a floating city. It's a scalable system. We like to think it's competitive, so we can take on whoever in the industry and go toe to toe with them. Again, so scalable architecture, depending how you want to do it. So either the preferred option is generally a centralized control room with a load of hardware, where in reality field boxes, I know it reduces cabling and things. We can do all of those things. Say small standalone system, remote subsystems, basically anything, whatever a customer wants, we should be able to deliver it, and like to think be competitive doing it. Whether it's basic or, like I say, the most advanced. So again, sort of a little bit more about the system. So again, that's showing a big monitor at the top. To be fair, in terms of cost, we probably put a couple of large screen, wide TVs. We take you into the playroom and Tamper, and we will have a video wall and all these wonderful things. But people tend not to buy it. Again, those curved monitors. If you come to see us at one of the shows, maybe we've always got that curved monitor. It still looks. We've probably been selling them for like 4 or 5 years. Still looks nice. Still looks, still looks cool. And then the tablets, sort of like say a desk-based tablet. And then going down from there, how we bring those things into the control system. So advanced process controls, data management, the connectivity, the configuration and maintenance tools, and asset performance. And then sort of down from there, some of the things some of those are new. So batch controls is a new one. We don't get too much request for it in the UK, but we've got some, batch controls for breweries and things like that. We can do machine controls and drive controls. Obviously been doing that, paper mills and things, a long time. So again, the high quality data for productivity and accurate decision making. This again is sort of how we bring it in. obviously in a timely fashion. The new product, we've not got the fastest cards yet in it. In terms of things like turbine controls, we do turbine controls. Normally they have to react within 5 milliseconds. So, you know, there's not a lot out there that sort of, you know, needs to be quicker than 5 milliseconds. So we can do that. You know, this is down to really, you know, how big is the system and how often you sort of, you know, need to poll it. How often do you need this data? And then looking at sort of where it's stored. So the bottom one, the DCS, you know, site-wide, you know, for basic reporting. Then maybe another server above that that'll do calculations. So we can do these now in what's called a virtual cluster, where you'll have all these things in one place. So moving up, kind of moving up to match the, I guess, data requirements of an organization. So as you get closer to the top, as I say, on a management level, you know, looking at sites with multiple locations, you know, a management team looking at stuff in the cloud and analysing that across, you know, not only we talk about the UK, but you could do it globally. You know, you really could sit there and compare. If you had a plant in France and a plant in the UK, you could compare the two and say, you know, why is the French one better? What do they do if the plants were identical? You could make that analysis and look at even, you know, I don't know, go down to shift patterns for argument's sake and say, you know, why is this one shift better than another? You know, if you needed to, you can analyse the data to that kind of level and have access to it, you know, from a management point of view. So as I mentioned about this trusted information framework on one of the earlier slides, I wasn't going to dwell on it there. Really, it's sort of dragging all these things in. So looking at the data, the framework of the data, sort of, again, the engineer and the historian, bringing stuff in. So the cybersecurity, making sure it's inherent by design, really, so that, you know, it's safe, and when you're using it, you know that it's safe. Like I say, the sort of cloud servers, the uniform model to access and operate data, and then the key enabler for digital transformation, offering this unifying architecture that ensures it's safe, it's reliable, it's efficient. So trying to pull all those things together in one place for you to access it as a customer. So combining, as you see, the crossover between the cloud, what's in the field, what's in the software, and knowing that all of that is in one place on a, you know, a system that's, say, open and secure. So should have said, really, at some point, it's an open protocol system. We talk to many other systems, so we're not fixed. You know, it's not like one where we say everything's got to be, you know, whatever it might be, Siemens, Profibus, Profinet. We can talk to, I can't legally say we can talk to anything because someone might invent a language tomorrow, but certainly all the major ones, you know, 99%, we can talk to pretty much anything. Standard stuff, Profibus, Modbus, OPC, whatever it might be. And that's the whole point. You know, we're not trying to take over the world by making sure you buy lots of Valmet little boxes. You know, any big system, like a waste-to-energy plant, you will have different manufacturers I/O. So there might be a bit of ABB, might be a bit of Siemens, might be whatever. You know, to run a whole plant, I think you very rarely get one manufacturer. And that, you know, by doing this, it then enables us. We've done some where, you know, where a plant gets like a really mixed bag and we do a retrofit and pull everything in, and it enables us to do that. I'm sure, you know, other people's products do the same, but yeah, we can do all these things and talk to different, you know, different systems replace different systems, but still offering this, this trusted information framework. So again, what I was just saying, open and secure connectivity. Again, this will come out in another drawing, to be fair, there's a better. Cybersecurity, for those who are an expert on it, and I'm not, we have, certainly even in the UK team, we've got one guy who's a real expert on cybersecurity. These are just obviously IEC standards that everyone's working towards. So, as I say, we've just launched the system where the first, like I say, we are the first one to have it, included. I'm sure the others won't be far behind, don't get me wrong. So again, some of the things that we've already spoken about, user management, role-based access control, where everything's traceable. And again, as I say, it's not just delivering the system, it's supporting it after that and doing the follow-ups. So obviously when when there are cyber attacks, and I think we all experience it. I don't know how you guys feel at the minute. Every time you pick up different devices, I start to think, my phone's updated, my TV's updated. So somebody somewhere's, come up with another form of attack, and all your devices are saying you must update. So imagine that on, if we're worried about phones and tablets and things like that. There's been instances, it doesn't get publicised very often because they get the money. Certainly in the States, there was a load of instances of power plants just being held to ransom, taken down, because they've got web-based access and it's not secure, and then all of a sudden, cashing in and just taking loads of money. And it doesn't get, like I say, it doesn't get as publicised as you think, because they don't want it publicised that they've been hacked. I remember reading one. It felt like they'd gone through the alphabet. It was like one beginning with A, one beginning with B. It's just like, felt like you were hoping your company began with a Z and you might be last on the attack list. But these are genuine concerns for anyone. As I say, for all this, I'm standing here telling you today, we've got this wonderful system. It's cloud-based, web-based, all these things. It's secure. I'm still getting people going. Don't really. Go to, for argument's sake, nuclear. You wouldn't want anybody from outside messing with a nuclear power plant. So, for as much as, yes, I'm here to tell you it's fantastic, there's still people out there saying, no, thank you. So again, just playing on some of the things I've already said about how we're structured, not just in the UK. Obviously work in the UK, but on a global basis. We've got at the minute 19,000 people around the world. Not all of them are automation, but looking after customers and service is a key part. What we do is obviously, trying to think of something to compare it to. I suppose a valve. It doesn't change a lot when you build it. You're not going to upgrade it. But we still support it with a control system. There are things that are outside of our control. So at the minute, if you've got Windows-based servers, there's a reason Bill Gates is one of the richest men on the planet, because every now and again he makes something obsolete, and we have to go around to customers and say, I'm really sorry, your server's going to stop working. Why is that? I don't know, ask Bill Gates. But obviously to do that, we have to be there to support the client. So and this new system moves away from that. So it runs in Google Chrome. So we don't have that dependence on Windows and Windows-based tools. So, but that's just, that's an example. I can't say a lot about it because all of the old systems are all, Windows-based. So yeah, this is a bit sales pitchy because it's kind of saying, if you've got you've got an old DNAe system, you should be thinking about DNAe and moving towards it. And this is the upgrade path. So, again, a little bit more about that. So it will, I guess it will start to come naturally. You know, we're talking to clients, but we launched it last year and I probably haven't bid that many, you know, of the new system yet, but we're kind of getting a mixed bag at the minute. So you might do, say you've got an existing waste to energy plant with our DNAe system. We're doing a carbon capture plant with DNAe because the requirements of the carbon capture plant lend itself to the new product. So then you've got a weird, you know what I mean, you've got a mixed bag on site where you're delivering a new product. Anyway, so you know, if you're an existing user, you would start to see the new product. Try and fly through some of this. Concerned about the time. So again, this is the sort of platform. Again, I think a lot of things I've already talked about in a different graphic. We've already had this slide on this one. So again, this is again something I was saying about the size and the architecture. So that's, you know, looking at you know, a plant-wide solution. I'm guessing that's a Valmet boiler, something I didn't tell you we made. Maybe there in the corner. Again, so these are like hundreds of thousands of systems, different process areas, different, like I say, not too worried about that. Just telling you how great we are. We can do everything from a small system with 100 I/O. Already said that. So the big stuff. This is kind of traditionally what you're used to seeing, what you can see. So again, these are the different levels. You can see the amount of firewalls in there that are there to make this secure. So the top level stuff is, like say, the industrial internet edge, reporting, data analyticals, stuff that might go outside of the plant, you know, on a local level. The bit in the middle is the bit that we're familiar with. So, you know, traditional control room with monitors, servers on site. It says there virtualized solutions, again, something we can do. And then down from there, how we connect to, so through the individual controllers, safety systems, whatever that is, Profinet, Profiboards, OPC. So that's just a traditional layout. You know, you're probably used to seeing that kind of drawing with obviously, you know, user-specific stuff. That's how we design a system. So again, going back to the user interface, so this room, I'm sure there's a pointer, but I'm not sure. This is actually our playroom in Finland. We call it the playroom because it's where we take customers. So again, these desks move up and down, and again, different screens. You can see what I said about the dark and light. So that's like a light background. You just switch the background. I prefer the dark. This is a tablet that I spoke about. So again, you can see, obviously there, you know, literally carrying the control system around the plant with you. Which, again, if I'd have said that 10, 15 years ago, maybe there was some tablets knocking up pretty robust ones, but maybe not with a direct connection like that. So again, this is, you know, again about the design, the tools that we use, how you configure it. So again, I'm not sure you guys are too worried about, you know, how we do that. Data management, so again, collection and storage, the models that we use, the tools, the dashboards, the reporting. Again, things that I've already touched on. These are the individual controllers. This is where the product starts to change. So again, these are based on scalable system. So things like this controller was used with the old system, as was this. These are just bigger, based on how many I/O points each controller would need. So this one will do, I think it's about 3,000. So depending on the system, a collection of those. This is the new one where you start to build this up. So it makes it easier to add redundancy just by adding on the side here extensions of controllers. Again, this one's saying 5 milliseconds. This is the I/O cards. No. These are the individual I/O cards. So again, they'd normally be either 8 or 16 way, wherever it might be, 2 different sizes. This is something called Signal I/O, which we've just launched, which is programmable I/O. So you can change it you can configure it during project execution and just move them around, so it can be analog in, analog out. So you can order a system if you're still, if during project execution you're still not sure, you could do it during final commissioning. So new controllers, new hardware, new I/O. More on cybersecurity. As I say, you'll have heard me say this quite a bit. And that's it. I'll try and leave 15 minutes if anyone's got any questions.